The author has wrote about this a couple of times, and I've covered this in some prior years. The 2038 problem is still a very real issue that basically nobody cares about. Nobody except for a systems engineer from SUSE called Bernhard M. Weidman, who's basically made it his mission to find these problems, report these problems, and in many cases, go and actually fix these problems himself and try to get these projects to actually care about this issue. Now, back a few years ago, this problem was still far enough away where it's not that big of a deal. You know, when it's still 20 years, 18 years, 15 years, now we're at 12 years away, it gets closer and closer. And the closer it gets, the more likely there is going to be a system in operation that has not yet been updated that is still affected by some of these problems. Hopefully when the problem rolls around, it's not going to be that big of a deal. It's going to happen. Maybe some little things are going to break, but everyone's mostly going to go about their day. But with so few people looking at this problem, it's kind of unclear exactly what is going to be left over, let alone all of the proprietary software, which I have no doubt hasn't been dealt with either. Now, I keep saying 2038 problem, but what does that actually entail? So you've probably heard about Y2K. This is also known as the year 2000 problem. So a lot of older software would store the year as 2 digits. Now, a lot of the time, the year is going to be displayed as 2 digits on a modern system, but in the back end, it's going to be stored in a different way. A lot of those systems actually just stored the year as 2 digits. So what was going to happen when the new millennium rolled over? It was no longer the 1900s, it was now the 2000s. Well, it kind of depended on the software, because it might crash, the number might roll over, and if the number rolls over, well, that breaks any date sorting system. And it should be immediately obvious why a date that's supposed to be recorded as tomorrow or a year from now is actually being recorded as 100 years ago. Now, when Y2K rolled around, nothing really happened. It was a pretty normal day for most people. People just went about their day and nothing really broke. But that happened because of years and years of developer effort and tons of government money being thrown at the problem to make sure it wasn't going to be an issue. But some very real problems did actually happen, just not at the scale that people remember. There were some warehouse stock tracking systems that weren't updated, which went a little bit haywire. A few random video rental stores sent out tens of thousands of dollars of late fees because, well, the movie you rented, that was due back 100 years ago. And being quite visible problems for these businesses, they got dealt with relatively quickly, but a lot of the media was saying, oh, planes are going to fall out of the sky, nukes are going to suddenly be launched, but a lot of these systems were not even built in a way that that was even possible to happen. So a lot of people assumed then that nothing happened, but nothing happened because a lot of work went into making sure that nothing happened. And as the name might suggest, the 2038 problem is also based on how dates are being stored, or how dates were being stored and shouldn't be stored any longer. So traditionally in Unix, the time on your system was stored as a signed 32-bit integer, counting up the number of seconds from January 1st midnight, 1970. Now, why that particular date isn't super important now, but keep that date in mind. The problem here is a 32-bit integer isn't actually that much time. So come 3:14 and 7 seconds AM UTC on 19th of January 2038, that number will run out of seconds. What happens then? Well, that depends entirely on the project. Most likely what happens here is the software crashes, no longer builds, and no longer functions. That's your best case scenario, but if it does continue functioning, well, then you have the issue of what happens with your dates now. Do you roll back to the earliest point of this and now you have a problem. Now you might say, well, aren't we all using 64-bit systems now? We store time in a 64-bit int as well, and that lasts for a while, basically 21 times the life of the universe. And this is correct. But the 2038 problem isn't a theoretical problem. There is still software that is available right now that you can run on your system that is still storing time in a 32-bit integer for one reason or another. It's up to those developers. They shouldn't be doing it, but these are still observable issues. And that is exactly why this post here exists. Today is Y2K38 Commemoration Day T-12. There are 12 years, a little bit less than 12 years left until this problem is unavoidable. Now, I do want to address this comment. By 2038, computers will auto-check every executable for the Y2K38 bug and patch it during runtime. Now, let's just assume that's how software actually worked, and you could just do that. How about we don't just rely on the fact that some magical tech might exist in the future that might be able to deal with this problem, and actually go and deal with the problem when we know the problem is there? Maybe, just maybe, AI will be good enough to fully deal with the problem by 2038, and this will be no longer an issue. But we're not there yet. So how about, we don't rely on that, and don't just leave it to last second. This right here is not an extensive list, and there are guaranteed to be other problems that have not yet even been discovered. So let's take a look at some of them. Firstly, break Mercurial. And this problem remains open with no further comments since 2023, but is something they say at the time is something they'll consider for the next format iteration. So hopefully that one is dealt with. Now, Mercurial, if it breaks, it's not that big of a deal because they would notice it at the time, and this would, actually get ironed out. Mercurial is generally not a critical piece of infrastructure where if it's not working properly, an entire system collapses. It's just developers can't do their job. Here we have Zio. This is a client-server storage thing, and there is a bug in the test suite. Now, again, a test suite is not the biggest of problems. If that breaks, you're going to be like, oh, the test is not working, but then you're going to spend a bunch of time being like, why is the test not working? The code's obviously correct, so it's probably a good idea to iron out these problems before the problem becomes a problem. And this was a very recently reported one. So this is something that was only just found. This means there's very likely more things that have yet to be found. There was what appeared to be a bug in NeoVim, but it actually wasn't a problem in NeoVim. It looked like it was one of the tests failing, but it was actually one of the libraries they used to do the testing. And when you start seeing problems like this in libraries, which this one is still open, that's going to affect a lot more applications than just NeoVim. Obviously, NeoVim's a big application, but NeoVim and everything else that relies on this, that's a lot more. This one has been dealt with in the code, but at least according to this, has not been added into a release yet. On that note, what might be a lot bigger of a problem is GCC 14 not compiling. That one, that one you definitely want to get fixed. Now, when I showed you a test failing earlier, that is not the only case with a test failure. We have Django GraphQL JWT, Python standard num, and CPython all having test fail. And this, I would imagine, a lot of cases is just due to the fact that when you're writing a test, you're not really thinking, hey, how do I make this long-term maintainable? It's more about, hey, I have a behavior I want to test right now. How do I go and test it? So you're not necessarily always going to use the best possible practices when handling dates in this situation. But also, like with the earlier tests, it just makes sense to deal with before you really need to deal with it. You're also going to see some tests fail due to SSL certs being set to a date before then. this is kind of a separate problem, but is also worth noting. Additionally, some protocols like SOAP/XML RPC and SNMP use 32-bit values, so implementations have to be smart in how they transport timestamps. I think some distributions already start to compile their 32-bit code with this right here, but that is only part of the solution. Code that handles timestamps regularly gets added or rewritten, and every time developers need to remember to not use int there, nor long on 32-bit systems, but long or int64t or just time t. Now there is a discussion open with the GCC devs to add a warning for int to time conversions, but at least at this stage, that hasn't really gone anywhere. It's mostly people arguing whether or not this is or is not a duplicate. The old bug 96570 was about time t to int conversions, and that is already covered by W conversion. But this issue is about int to time t conversions. It probably needs a new way to tell GCC that anything that goes into time t should be able to hold more than 31 bits of a signed int, because that would overflow soon in 2038 and will cause a problem. Now, the only actual proper argument about this is whether or not this should be in GCC or should be somewhere closer to the language front ends, closer to the languages, actually built on C. Again, what I've shown here is not the extent of the problem. There are guaranteed to be other things that have been yet unfound. There are other things that are not listed here, and some of those are going to be more test suite problems, and again, it doesn't really matter. But there's very likely some very core problem that still exists that is going to cause a serious problem come 2038. Now, does it need to be dealt with immediately? No, not really. But the longer that is waited, the more likely it's going to be in a deployment that is still in operation past that date, which has not been updated. So, if you're building any project out there, at least once, go and do a test, build it past the date for the 2038 problem, and if there's a problem, there's a problem. That problem's probably not going to go away without somebody dealing with it, so at least document it down at a bare minimum. And hey, if you've ever wanted to help out in the FOSS world, this is a great way to do so. Spin up a VM, set the time to sometime after 2038, and build stuff. Just build random software you use, test it, and see if everything works. So let me know what you think's going to happen when 2038 rolls around. Do you think there's going to be a bunch of unresolved problems and it's going to be a big deal? Do you think it's going to roll by with not really much happening? Do you think there's going to be some big tech stories at the time? I'd love to know. So let me know your thoughts down below. If you liked the video, go like the video. If you really liked the video and you want to become one of these amazing people over here, check out the Patreon, subscribe to Daily Bearer Pay, linked in the description down below. Go subscribe as well. That'd also be nice. Yeah, just see what breaks.